Here's some important information you should remember. An even number of negatives will always equal a positive, and an odd number of negatives will always equal a negative. And now that we've gone over the algebraic tests for symmetry rules, let's go ahead and begin to solve a problem. It says without graphing, determine whether the equation has a graph that is symmetric with respect to the x-axis, the y-axis, the origin, or none of these. So let's start with the x-axis first. Remember, when we want to find out whether it's symmetric with x, we change y to its opposite. So once we do so, it's going to look like so. We can simplify that if we like and multiply the entire equation by -1 so that this will be positive, that y. When we do that, this is what we're left with. It is not the same as what we started with, so we have to conclude that the graph is not symmetric with respect to the x-axis. And now we want to test to find out if this same equation is symmetric with respect to the y-axis. To find that out, recall, all we have to do is change x to its opposite. And if we wind up with the same equation we started with, then yes, it is symmetric with respect to the y-axis. So we're going to go ahead and remove the x, replace it with -x. Remember, an even number of negatives will always equal a positive, so when you multiply all this out, it will be 2x to the 4th power, which means that it is the same thing as what you started with. So we can conclude that the graph is symmetric with respect to the y-axis. Lastly, we want to test to see if this same equation is symmetric with respect to the origin. So recall, we just need to remove x and y and replace them both with their opposite. Once we do that and simplify, we can see here that it is not the same as what we started with, so we have to conclude then that the graph is not symmetric with respect to the origin.